Dear students, we have seen till now the sludge casting, shell molding, ceramic molding, investment casting and die casting technique. Okay, now the next casting technique we are going to see is that the centrifugal casting technique. Okay, so you can see the diagram here. So in this casting process we are using the permanent mold, and this mold, when the molten metal is get poured, it is continuously rotated unless the molten metal it get solidified. Now here, for rotation of this, see, this is the rotating mold and we are pouring the molten metal here. Okay, so there is tremendous rotational speed of this mold, so that there will be the production of centripetal acceleration of about 60 to 75 times g. 60 g to 75 g is the centripetal acceleration is going to produce. So what happened here? See, molten metal, the heavier molten material is go around the surface of the casting, and which are the less dense material or lighter impurity, I can say, which will be get collected near the axis of rotation. Please remember, in centrifugal casting technique we are having the permanent mold which is rotating with very high speed, so that we can produce the acceleration, centripetal acceleration around 60 g to 75 g, and with such a high rotational speed, what happened? The heavier molten metal is going towards the outward surface of the casting, whereas the lighter density or low density material, rather lighter impurities, get collected near the axis of rotation. So a simple way we are having to explain this, we are having the centripetal force as mr omega square. So if Fc is proportional to what? Mass is nothing but volume into density r omega square. So we can write this centripetal force is proportional to the what? The density of the material. So higher the density, lower will be maximum will be the centripetal force, and that's why the heavy density material will go onto the outer surface, whereas low density or less density, lighter density materials or impurity will be collected at the center or at the axis of rotation. Now student, the very important and basic application of this process is to produce the hollow pipes. किसके लिए यूज होता है? बेसिकली फॉर प्रोडक्शन ऑफ द hollow pipes which are used in the water supplies in the cities. So these pipes are basically made up of this centrifugal casting technique. Another example or another applications of this, say we are having the LSB. LSB means large size bearings. So the inner and outer rings of the LSB, large size bearings, are made by this centrifugal casting technique also. Or even we can able to produce the washers or bushes, pulleys, wheels by the centrifugal casting technique. The thing is that, very simple is that, there is no need to produce the hollow portion into the casting. Okay, generally to produce the hollow casting we are require the core, but in case of the centrifugal casting technique no core is used. We need not to have any kind of core. We can have the rotation of the component so that material will go along the periphery and the circular parts can be produced. Now the second important thing in this centrifugal casting technique is that here when we are talking about the steel castings, so steel is an alloy of iron and carbon, we know very well. So what happened? The centrifugally casted component, for this example is steel, are not having the good machinability, or they are having very poor machinability. Why it is so? As we know that steel is having the alloy of iron and carbon. Now because of this centrifugal force, we know that the density of iron is around 7.8 grams per cc, whereas density of the carbon will take it is around 1.2 grams per cc. So there is a huge difference in the densities. So what happened during this rotation, during this centripetal action, what happened? Definitely iron will try to go on the outer periphery, whereas the carbon is try to be at the center of axis of rotation. So because of that, what happened? Carbon or iron, they are trying to separate, but we know that iron is having huge affection towards the carbon, so it is not simply get separated. So what happened? So in such a steels, if we look at the microstructure, so there will be rich in carbon and poor in carbon, rich in carbon and poor in carbon, the layer of the material you can see. And because of this is the non-homogeneity, or this effect is known as the segregation effect. What is this effect? Is known as segregation effect the steel undergoes in the centrifugal casting technique. That is why, see, the material is not uniform or homogeneous, so machining is quite difficult. That is why, because of the segregation effect, see, this layer is rich in carbon, and this is poor in carbon. Like that, layer by layer structure we are getting, and this structure is actually not easy to machine. So the centrifugal casted component is having the poor machinability. Please remember this, because of which effect? Segregation effect. Understood? Now, by using this centrifugal casting technique, whether we are only going to produce the hollow parts, so the answer is no. We can also able to produce the solid parts also. We are also able to produce the solid part. How? By keeping the mold cavity on a particular, any single half of this mold, any single half. You just put your mold cavity in any single half of this mold, then you can able to produce the solid castings also. Please remember, the centrifugal casting technique, no doubt hollow parts are made, but we can also produce the solid parts by using the centrifugal casting technique also. Understood? Very good. Now see here, while looking to the diagram, this is a mold, this is a ladle, we are pouring the molten metal and mold is rotating. Now here, see, when the axis of rotation and the axis of mold are coinciding, see, when the axis of rotation and axis of the this rotation and axis of the mold are coinciding, are same, then the technique is known as true centrifugal casting process or technique. Axis of rotation and axis of mold are coinciding. This is known as true centrifugal casting technique. Okay, and when there is an offset between the axis of rotation and the axis of mold, okay, then this casting process in the centrifugal casting is known as the semi-centrifugal casting technique. Okay, semi-centrifugal casting technique. This is also used for producing wheels, pulley, etc. So true centrifugal casting and semi-centrifugal casting is again the sub casting techniques for this centrifugal casting technique. Okay, now see here. Now let's see some little bit about the centrifugal force. We know that the centrifugal force is equal to mr omega square. Okay, and you know force is equal to what? Mass into acceleration, isn't it? So here this mass and mass get cancelled. Say this acceleration is equal to r is what? d by 2, isn't it? D by 2, and omega is what? 2 pi n by 60 whole square. Now if I want to find out the constant for the centrifugal casting technique, so it is, see here, it is d into 4 pi square n square divided by 60 square. So acceleration, how much centripetal acceleration is going to produce in this technique? Around 60 to 75 times g. Okay, so if I put here value, say 75 times g into 60 square divided by this 4 pi square, these are the values, say constant we are getting here, which is equal to what? D into n square. Understood? So this value d into n square is nothing but the constant for this centrifugal casting process. Please remember, says d into n square, d into n square is the constant for this centrifugal casting technique. You can calculate the value. Okay, when the acceleration, I am saying 75 g, you can have 60 g, like that, 60 to 75 g. Now when I ask you to find out the constant for or find out the value of any of these, one of the value I ask you to find out, say this is a pipe, the cast iron pipe, having the inner diameter say di and outer diameter say do. Okay, I will write capital here, capital D. Now this is the known value and I provide you the value of n or any one of the above. We can calculate, suppose, but here the d can be taken as the average, d average, which is equal to what? So d inner plus d outer divided by 2. Understood? So if I ask you to find out, I have given with the diameter, I ask you to find out the RPM of the mold. So this is the value you can get, divided by this diameter and take the root, you will get the revolution of the mold. In this way we can calculate any of the asked value, isn't it? So please remember, this is for centrifugal casting process. Now see, long year back the question is asked on this, and even last 2 years, I think 2018, in PI, Production and Industrial Engineering, they have asked this question based on this constant for this centrifugal casting. The numerical was asked for 2 marks. So please remember about the things which I have already discussed about centrifugal casting technique. And what are the applications? Please note down the applications. I already explained, but I am writing here. So where it is useful, say the large pipes made up of say cast irons in water supply, then the inner and outer rings of large size bearings, we are using this into the bush, or bushes are made, or the washers. Then it is also used in the making the wheels and the pulleys. So these are the applications where these centrifugally casted components are used. So this is the end of centrifugal casting. Thank you.